concepts related to IPv4 addressing, and there are some important points as well which has to be discussed so that when we discuss the subnetting concept, it's going to help. Right. So let me share my screen. Okay. So, uh, so you can make a note of the points which I'll be telling you right now, right? So there is one IP rule which is important. So the basic of this particular IP rule, and I am telling this IP rule considering IPv4 only, not IPv6. So we will discuss IPv6 in the later course, but regarding IPv4, there is a IP rule using which you will be having, you'll be able to configure subnets. So the basic IP rule is that there must be at least at least two bits remaining in the host part, in the host part. You can make a note of it. I'll explain you shortly what is host part, what is network part and all. So this is the important point. The IP rule says that minimum of 2 bits must be remaining in the host part in order to create subnets, right? So we'll come to subnetting, and the host and network bit shortly. The next important thing is, I believe I have already told you regarding APIPA, right? So what does this mean? This is nothing but automatic private IP assignment, right? So what is the job and role of APIPA? It is nothing but, let's say your DHCP server is there. DHCP server's job is to provide IP address to the host machine along with the other IP related parameters such as DNS and default gateway, right? So when DHCP does its job, let's say your DHCP is configured to provide only 10 IPs, right? 10 IP addresses, and somehow this particular pool of IP is exhausted, and there is a 11th machine which requires an IP, but your DHCP is not providing IP. So your machine on its own configures a default IP which is actually reserved by IANA on each and every TCP stack. So that is not going to be used for any sort of routing purposes. So that IP is nothing but 169.254.x.x, right? So by x.x, I mean it can range from any number to from 0 to 254, right? So your device, if there is no IP addresses which is provided by your DHCP server, your device will be stuck on this particular IP address, and the moment you see any IP address within this range, you can immediately go and check your DHCP server. So this is how you will be understanding how to troubleshoot network issues in an infrastructure, right? So this is important. These 2 bits are very important, right? So after this, now we'll jump to the concept of network and host part of the IP address, right? So basically, as I earlier told you, the class A IP address, right? So the class A IP address is ranging from what range to what range? 0 to
127.
127, right? Now, when we talk about class A, the class A has one network bit, right? It has one network bit, not bit, it will be network portion or network octet, right? And three host octets. Right? How do you write a class A? So it is nothing but it will be having a network host dot host dot host, right? So when you see an IP address within this range, let's say, let us take an example here. So let's say I give you an IP address 20.0.0.0.1, right? So according to this, the moment you get an IP address, IPv4 address, no matter in like in whichever organization you are and whatever work you are doing, if you see an IP address like this and you see that it is 20 here, no need to check this portion of the IP address, because we have learned that from 0 to 127 it is class A. So you can immediately understand that this is a class A IP address, right? And the network bit and the network portion over here is 20, right? So when you write a class A IP address and you want to because IPv4 generally relies on subnets. So without informing the device which particular portion is a network portion and which particular portion is a host portion, you will not be able to route the packets from one destination, from one source to another destination, right? So to append or to make the computer or the TCP IP stack understand which portion is the network portion and which portion is the host portion, there is a predefined way of annotating these things. So here, what we generally do is any portion which is network, we annotate it as 255, and which is not a network bit or which is not a network portion and it is a host portion, we mention it as 0.0.0, right? So now if we put this both together, a class A IP address can be written as network.host.host.host, right? And this can be annotated as 255.0.0.0, right? So when a IP address, let's say there is 10.0.0.1, now based on that, the computer stack will understand, looking at the subnet mask here, it will check that okay, 255 is in the initial octet from the left side. So this is the network bit of this particular IP address, and all the other bits are host bits, right? So now now we will come to the point of how many number of networks class A has, right? So I earlier told you that each octet of an IP address is having 8 bits, right? So let's assume 1, 2, 3, 4, 5, 6, 7, 8 dot. And since we are not having any network bits after the initial octet, 0.0.0 is the value. So it will not be 0.0.0, it will be 8 zeros here. So it's a waste of time typing that, that's why I'm not typing it. So it will be 8 zeros here, and here since all the 8 bits are network portion, so these are all considered as ones, right? So how many ones are here? 1, 2, 3, 4, 5, 6, 7, 8, right? So in total, how many network can we create using a class A IP address? So the simple solution to that is 2 to the power of 8, right? And we remove 2 to the power of 8 minus 1, which we remove for the network portion of that particular network address, right? So this will be equal to 255, and that cannot be 6. So 2 to the power of 8 minus 1 should be 126. Why is it giving the wrong calculation? 128, right? So here I am mentioning it as 2 to the power of 8 minus 1. So let me just write that down so that it is clear. What I am trying to write there is 2 to the power of 8 minus 1. So this 8 minus 1 is in the power of 2. Now for class A, why we remove one address is because there is a IP address there 0.0.0.0.0, right? And the same thing is having a network address as well. So the class A will have one network bit remaining for itself. So we remove that from the calculation. So when you do this, you will be getting 128. So 2 to the power of 7 is 128. But since I earlier told you that class A has a default IP 0.0.0.0 as reserved, and we have a loopback address there 127.0.0. or x.x.x.x, this particular range of IP is also removed. That is why we remove another two IPs from this. So the overall network IPs what we will have in class A is 126, right? I know it will be a little bit confusing, but once we complete all the three classes of IPs, you will get a clear understanding of how we are calculating this and why we are subtracting this. And obviously, if you have any doubts, you can ask me the questions once we are done with all the three classes of IPs, right? So now, if we see in a network, how many, in a class A network, how many host bits are remaining with us? So overall, we have 8 into 3, 24 host bits are remaining with us, right? And from this, we remove one address for the network, right? And we remove another address for the broadcast purposes. So in the later sessions, when we will create IPs or networks, or we create subnets from a specific network, we will have different things what we will like create there. The number one thing will be we will be creating a network ID, right? For that network ID, we will have n number of networks according to the host portions. Then at the end, we will have a broadcast ID, right? So this broadcast ID and this network ID is what we are subtracting from here, right? So when you subtract this, around 16 million some host IPs you are getting, 16 million plus. So overall for class A, the networks, the number of networks what class A can provide you is 126, and the host portions, the hosts are nothing but, let's say these 126 networks are there. So each network, each 126. So from this 126 network, let's assume that there is one specific network. We assume for each network there will be 16 million hosts. 16 million hosts, 16 million plus hosts. So you are getting an understanding, right? Like one organization, let's say they have multiple devices within their infra, and they want to route their traffic to each other internally within their infra, right? So in order to do that, they will be utilizing class A because it has the highest number of host portion, host network what we have, right? So each network from this 126, so these 126 into 16 million, so those many IPs will be there for them to use, right? So from 126, let's say first IP we consider. So for that first IP, there will be 16 million hosts. For the second IP, there will be 16 million hosts. For the third IP, also there will be 16 million hosts. So by IP over here, I mean the network ID, right? Each network ID will have 16 million hosts, right? Now we go to class B, right? So in class B, there are two network bits and two host bits. Simple, right? Now here each each octet is of 8 bits, right? So overall, how many networks will come here now? 2 to the power of 8 plus 8, 16, right? And we remove two IPs from here because each network portion has its own bit reserved for itself. So we are removing this reserved host bits from those networks. So we are removing two here, and whatever value we get, around 16,000 some change value will get. So if you use a class B IP, you will be having these many 16,000 number of IPs. So what about the host portion? It will be 2 to the power of 8, 8 plus 8 is 16. And from the overall figure of this, we will be removing two IPs, which is for its own network and broadcast purposes, right? So if you remove that, you will get around 65,000 some change IPs you will get, right? So all in all, if together you see this, from the 16,000, if you take one network ID, right? So for that one specific network ID, you will be having 65,000 IPs for you to utilize internally, right? So like that, overall IPs that organization can use is 16,000 into 65,000. Whatever value we get, that's the overall number of IPs the infra can use, the infrastructure can use, right? So that is how we calculate class B. Now, if we come to class C, here we have three network bits reserved and only one host bit for us to utilize, right? Now, if we see here, the calculation goes like this: 2 to the power of 8 plus 8 plus 8. Here we are calculating networks first, right? So all the networks, 8 into 3 is 24. From that, we remove the three IPs, the three bits which are reserved for each network, each octet, and then whatever value we get, that's the number of networks we get. So I don't know, we calculate it. Just a second. I don't know, something in millions you will get. Uh, Something in millions you will get here, the value, the networks. For the host network, the host bits, the number of hosts, we will get 2 to the power of 8, 2 to the only because 8 bits are there, and you will remove the broadcast and the network portion of that particular network. So that will come about as 254 because 2 to the power of 8 is 256. So these many host bits and these many network bits. Now, now the thing is, if we go one by one, let's say class A, right, class B, and class C. Let's make a so here we have one network, here we have host, here we have host, right? Here we have two networks, and here we have two hosts. In class C, we have three network bits and one host bit, right? Now, how many networks are there here and how many host bits are here? So we just did a calculation for this. I'm just writing in a tabular format so that it is a little bit, yeah. So in class A, how much did we calculate for the network? So it was 126, right? So 126, right? And 16 million hosts. Okay. For this, we had calculated 16,000 of network bits and 65,000 of host bits. You need not remember these numbers. I want you to remember the calculation. That's it. So the network bits here for the class C, we have how many network IDs did we calculate here? Something in millions. So let's assume 2 plus millions, right? And the host bits will be 254, right? So is this clear? Any doubts here? So you can ask me the question now, or the calculation part, or where you didn't understand how these figures are coming. So the class A will be used by a larger organization. This will be used by a medium organization, and class C will be used by small organizations. Why? So why this is considered for larger, why this is considered for medium, and why this is considered for smaller? The answer is simple. Post calculation, we see that there are 16 million plus host networks, what we are seeing here. So host networks are the usable IPs what this organization can use. So from these 126 networks, they will not be using 126 networks altogether. They cannot provide each device with single network IP. No. What they will do is they will take one IP from this, they will perform subnetting to it. Subnetting, after performing subnetting, they will get, for each IP they will get 16 million IPs, right? So based on that, based on this figure, we consider class A should be used by larger organizations. Next, if we see class B, we see a little bit lesser amount of IPs, but significantly good. So 65,000 of IPs for each network they are getting. So if they take one network IP from that, one network ID from these 16,000 IPs, if they take one network IP, and from that, if they do subnetting, they will get this many IPs, and they can use those IPs here, right? So this is the raw calculation what I am telling. So basically, this is like if you take this format here, and you have you from this 126 you take one of the IP, so they can use 16 million plus IPs. From these 16,000 IP, if they take one IP, they can use 65,000 IPs. If from these 2 million plus, if they take one of the IP, they can use 254 IPs for hosts. And now if you see, there are only 254 IPs for each network. So that means very small organization can use it. But let's say your organization is small, only 50 to 100 employees are there. You can use 192.168 range of IP, right? So for now, I do not want to go a little bit deeper because I know this calculation and this understanding this portion is a little bit difficult. That is why I'm not talking a little bit more about subnetting as of now. I want you to ask me questions if you have any doubts here.
Sir, about 128. please go through network host layer. You mean A, we have A, no, sir.
Class A, okay,
Class A. Please
okay.
go through it and please tell 8 minus 2 power 8 minus 1. What is that, sir?
2 to the power of.
You have written 2 to the power of 8 minus 1 and 128 minus 2. What is that?
Right. So let me explain that. So when you calculate the network portions, right? When you calculate the network portion for class A, we have 1, 2, 3, 4, 5, 6, 7, 8. Are these 8? 4, 4, yeah, 8, right? So the remaining are host portions. So let's forget about that. So we are calculating how many networks are there in the class A. So here, if you see the calculation, because these are in a decimal format, we take 2 to the power of 8 network bits are there here, right? 8 network bits are here, but we remove the one reserved bit for that specific network, right? So
For
when
network ID,
not for network ID. The network ID comes for the host portion. So we remove this one specific bit for the class A. We are just reserving one of the network bits will stay reserved because we cannot completely utilize the whole network, right? So if there is class A like this, so at least this IP should be reserved inside. So for that purpose, we are removing one bit from it. Similarly, for class B, what you will do, you will calculate it like this: 2 to the power of 16 minus 2, because you are removing from each octet one bit you are removing, assuming that you are reserving that for the network portion of that. But it is not network ID. You are just reserving the network octet, whatever network octets are there, you are reserving one of the bit from that. You are not reserving the network ID. Don't get confused, right? So the network ID and the broadcast ID comes in the host portion. So during calculation, just remember one point, that is, if you are trying to calculate for any class of IP, how many networks or how many host bits are there. So we're talking about networks here. So if network, how many networks are there, if you want to calculate, there we cannot entirely utilize the whole network according to the class. So according to class A, we have only one network bit, right? So when we have only one network ID which is reserved for it, so from 8 bits we will remove one of the network bits, and then we will calculate the value for the number of networks, right? And the next thing is, because I told you in class A, 0 and 127 range of IPs is something which we do not use in the subnetting portion or in the networking portion. We do not use it for IP addressing at all. These are something which is reserved. This is a default IP and this is the loopback address, right? So when you calculate the number of networks, you have to assume that you are not considering this, and that is the reason why when you do this calculation here, that is 2 to the power of 8 minus 1, which is 2 to the power of 7, which is 128. From that you remove the two networks which are of no use to us when we calculate IPs. So you remove those two, and that is when you get 126 number of network IPs, network IDs. But in class B, that is not the case. In class B, there is no such restriction wherein some of the other IPs are reserved or they are not supposed to be used. No. So when there is no such restriction, what we are doing is we are just simply removing the network bits from each octet for class B and directly writing the value. Clear? Hello?
we are taking 2 to the power of 7. The
Mm-hmm.
value is 128.
Mm-hmm.
Again, we are taking minus 2.
Yeah, we are removing -2 because I told you how many class A IPs are there. What is the range of class A IP? 0 to
We can write 127, but we can write 126
exactly.
because 127 is loop back, right?
Exactly. So when you do that, so that 127 you are not considering for networking portion, right? You will not be using for any sort of routing purposes. Got my point? So what I'm trying to tell you is from class A, we will never use 0.0.0.0 or we will never use 127.0.0.0. So these two IPs we never use at all. So there is no meaning in calculating those two IPs in your networking calculation also. So simply what we are doing is we are removing from our whole network IPs, whatever we are getting, we are just removing these two IPs. That's it. And that is how we are getting 126 network IPs which are actually usable. These two IPs are
Understood,
only
sir.
right. Any further queries?
In the same scenario, we'll be calculating class B, class C also, right?
Yes. So for class B, you will be 2 to the power of 16 because there are 8 bits in each network portion, right? 2 to the power of 16 and -2, you are removing that reserved portion of the network. From each network bits, you are just removing that too. But
Okay. In the
yeah,
same scenario, in the class C, we should take 2 power 24 minus 3.
exactly.
Okay. Okay. I got it.
Simple. So,
But we will not take any again we will not do any subtraction because at first we took 0 and 127. So
mhm,
in the B and C there is no subtraction.
exactly. There is no subtraction because there is no restriction at all in B and C.
Yes sir, got it.
Yeah. Great. So this is clear for everyone now, I believe.
Yes, sir.
Yes sir.
Great. And make sure that you're taking notes for today's session because after this session, for maybe 2 or 3 more sessions, we will have difficulty calculating subnets and all. So for each class of IPv4 address, what we are discussing here, we will have subnetting sessions for each. So we'll come slowly from class C, class B, class A. That I'll do. That's not a problem. But understanding part is up to you. So for that purpose, I want you to make sure that you take notes.
Yes sir, we are taking notes.
Great. Now, now another important concept. So until now, I've been talking about private IP address, right? So I've been telling you that the infra can route the traffic internally, right? And the infra can route the traffic externally. How can it do that? Obviously using routing protocols. But before that, there is an important concept that is private IPs and public IPs, right? So what's the major difference among this? So private IPs are non-routable IPs externally, right? And public IPs are routable IPs externally. Okay. Now, the next thing is that these are free IPs. So nobody is going to ask you money for using these IPs because they are not going to be used externally. You are going to use it on your within your internal network, right? So these are free, but these are chargeable. You have to pay some amount. So you are taking internet from your ISP. They are charging you internet service fees. So they are providing you a public IP. Using that public IP only, you are able to communicate. You are on this call because of that public IP. So you're paying that. So that is why it is called as chargeable public IP, right? So that's the basic difference. Now, how do you differentiate what is a private IP and how do you differentiate what is a public IP? So the simplest thing is you must remember what are private IPs. If you remember this, you need not learn about public IPs and the range of that. So simply just memorize this particular thing, that is in class A, right? In class A, if 10 dot x dot x dot x of IP is there, this is a private IP. In class B, if it is ranging from 172.16.x.x to 172.31.x.x, this is a private IP. Okay. Then in class C, 192.168.x.x, this is a private IP. That's it. Simple. If any of your devices are within this IP or this range of IP or this IP, it's a private IP. Simple. Is that clear? Now, any IP apart from this particular IP, apart from 10, let's say there is IP 11.1.1.1. What is this IP? Is this private or public?
Private.
No.
Public.
Sorry, public. Public.
Yeah, it should be public IP. What about 10.200.253.254? What is this?
It's private IP.
Private. Great. What about 192.168.70.1?
It's private IP only.
What about 193.168.0.1?
Public.
It is public.
Great. So that's it. So that is the difference. Now, what about 172.18.0.1?
Private.
Right. 172.32.0.1.
Public.
Great. That's it. So I believe this is clear for everyone. So you can memorize this. This is important because when you try to troubleshoot any sort of issue or somebody has provided you a system, they need you to troubleshoot the issues. You first check this and then you check the next part, right? So based on which particular IP address they are on, that decides like after this how they are routing to the internet. So definitely when you route to internet within your home Wi-Fi also, if you open the interface details section of your device, you will see either this IP or this IP or this IP. That depends. That depends on your ISP provider or that depends on your DHCP, which in our general sense is the router at home, right? So every one of us has a router or we are using mobile devices and connecting our laptops or devices using mobile hotspots, right? So those hotspots or those routers, they have a DHCP server inbuilt in that, right? So that DHCP server has a pool of IPs which it stores. So it can store the pool of IP within the range of 192.168.x.x, or it can store it in the class B private IP range, or it can store it in the class A private IP range, right? So that's the basic thing about the private IPs and the range of private IPs, right? Now, apart from all these IPs, everything is public IP, which is chargeable. Simple. Okay. Now, Now there is a concept apart from IPv4, we have IPv6, right? So as I earlier told you, IPv6 is something which is recently it's coming into picture, right? And it is a little bit complex than the IPv4, to configure within the infra, right? So for IPv6, the benefit with IPv6 is that it does not rely on the subnets, right? So since we are talking about subnets, let me just introduce you what subnets is or what is subnetting. A network within a network is subnetting. Simple. That's the simple definition of subnetting. So when you divide a network into usable host IPs is subnetting. It completely decides how you understand the topic. So if I take you back here, what we have just discussed, I told you that let's discuss about class C because that's the simplest of all. So I told you that class B has 2 million plus of network IPs, right? And 254 of host IPs, right? So that means if I consider any one network among class C, let's say 192.168.0.1, let's assume this is a network, right? So in this network, there will be around 254 of host IPs. So how will those host IPs be visible to you? 192.168.1.1, then 192.168.2.1, like that, so on and so forth until 254. You will have overall 254 IPs there, right? So a network a network within a network is called as subnetting. Simple. And this we will be calculating based on few two or three examples in each and every class of IPs. So very important when we are actually working. It's not like you will sit taking a paper within the organization and calculate the subnets and the networks and all. It's not like that. But the concept is what is important. Once you understand this, you can definitely go to Google and type the network and the subnet, whatever you want, and you can fetch all the results. That is easy. That you will be doing when you're working. But if somebody asks you question or they are asking you to calculate this, we need pen and paper. And for that, the calculation is important. So maybe in the next, maybe tomorrow or day after tomorrow, we'll do that. That's not a problem. But subnetting is this. So it is nothing but a network within a network. Simple. We'll discuss about that further. Why I introduced that is because I was telling about subnets here. Now, so IPv6 is a little bit complex than IPv4 and does not rely on subnets. That's the advantage of IPv6. But IPv6 has another drawback, that is it does not support broadcasting, right? So you cannot use an IPv6 broadcasting. There is no broadcasting feature for IPv6. Let's say there is a IPv6 organization here and there are n number of devices, n number of users, and they want to send the information to each one of these locations at a time. They don't want to send it only for few and then only for few. No. So IPv6 will not be able to do that. For that, they will have to use IPv4. Or currently what they do is they NAT the IPv6 to IPv4 and then they route the packets. So this is what basically infrastructures are doing, but no need to confuse as of now. This is the basic concept, right? So if you see this router is trying to send all the packets to everyone, this is called as broadcasting, which is not supported by IPv6, but it is supported by IPv4, right? So now I think I have some image for IPv6 to show you, right? So so if you see this over here, IPv6 is in hexadecimal format, hexadecimal format, and it is divided into 128 bits, right? And 16 bits each octet. 16 bits of each octet is there, right? So it is like this: 16, 16, 16, 16, 16, 16, like that. So in hexadecimal, not in dotted decimal format like IPv4. So that's the major difference among IPv6 and IPv4. It is denoted in the form, IPv4 is denoted in the form of decimals, as we earlier discussed, like this. So there will be a number here, 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 and here, and it will be differentiated with dots. And then we will add the subnet of that particular IP, so that the device can understand to which particular class of IP it belongs to. But here we do not need that. So what happens is, here we use the hexadecimal format for the purpose of subnetting. So the subnets are nothing but, those are also network within network, but they do not rely completely on subnets. They just see the global routing prefix and they route it to the interface ID or the host here. So interface ID or the host, right? So from this 128 bits, what you can do is, if you see the diagram over here, this is the global IPv6 address. IPv6 address, right? In this, if you see, the global routing prefix is something which stays intact. So this stays intact. That doesn't mean that the value doesn't change. This global routing prefix is for each and every organization. When they purchase an IPv6 address, they will have a global routing prefix. Let's say your organization purchase, or maybe you and me purchase an IPv6 address. Your ISP has provided you an IPv6 address. For that IPv6 address, we will have a global routing prefix like this. According to this, the destination will understand, okay, it has come from this particular routing prefix, so this person I know, let's accept the connection, something like that. Just an example, right? So when you see the IPv6 annotation here, it is annotated as hexadecimal, right? And this is overall 128 bits, 128 bits, 1, 2, 3, 4, 5, 6, 7, and 8. 8 octets of 16 bits each. Right? So this is the notation of IPv6 address. Do not worry, we will not be discussing much about IPv6. We will not be actually be capable of checking IPv6 and maybe calculate it. This is something which is done using tools which we use online. So not a problem, no need to worry, but understanding is important, right? So the major important portion of a global IPv6 address is this. So to which particular subnet it is belonging to and to which particular global routing prefix it is belonging to. So it is occupying 48 bits. So that means 1, 2, and 3. These three portions are the global routing prefix, right? This 16-bit is the subnet and the remaining is the interface ID or the host ID. Simple, right? Now, I have shown you this diagram. What is this? This is nothing but, let's say I told you in class A, I'm sorry, I told you about IPv4 and I told you there is private IP concept in that. and there is public IP concept is that. Similarly, the above one is used for public negotiations or public interaction, public IP. So this is the format how IPv6 will look for public IPs, and the below is the IP for the private communication. And in this private communication, we do nothing but we add the administrator or the network admin will add their own hexadecimal notation for the private IP. And if you see here, this 8 bits is reserved. This FD is the hexadecimal notation for that particular company. So I have fetched this information from online. So on that particular site, they had some example given there. So I took a screenshot of that. So this FD is the hexadecimal notation for the private IP, right? And this particular private IP is appended to the same thing here. So if you see from this 16, the 8 bits are reserved for this FD, and remaining 8 bits and the remaining 16 and 16 this bits are for the global ID. That's the pseudo random whatever value is there. And then the subnet and the interface ID remains the same, right? So in brief, to understand about IPv6, what you must understand is that it's a 128-bit length of hexadecimal notation, right? And it is not not capable of what? Broadcasting. But it introduces us to the concept of any cast, right? Very important. So these days, we all have smartwatches, we all have smart devices around us. How are they communicating with each other? Any idea? I'll give you a small example. I believe everybody has a smartphone and everybody has a smart TV at home. So sometimes at home, when you're connected to your Wi-Fi, to which your smartphone and your TV is also connected, you might see that you might get a notification on your phone that play or pause this particular TV channel or something like that. Anyone had this thing? Anyone observed this?
Yes, sir.
Right. So how does that happen? That happens because of any cast. You did not do it for sure. You never told your device to go connect to the TV. But how is it trying to connect? It is trying to connect using any cast. So any casting is nothing but without you interacting with the IoT device, Internet of Thing device, which are like smartwatches, smart TVs, cameras, and all. What they do is they advertise themselves. So they advertise themselves to the nearby devices. So they keep on broadcasting like this. So not broadcasting, they keep on any casting. They keep on informing that, hey, I'm here, my IP address is this, I'm hosted at this particular IP address, my interface ID is this, my subnet is this, my global ID or whatever it is this, something like that, right? And if you are within that network and your device is actually enabled for the acceptance of these communications, automatically you will get a prompt, okay, pause this channel or play this channel, something like that. So that's just a small example what any casting is capable of. This functionality is not available in IPv4, right? So IPv4 is not at all capable of doing this. That is the reason why only the newer devices have this capability and the older devices are not capable of doing it. Because the TCP IP stack of the newer devices have this IPv6 inbuilt in them, right? So that's one thing about IPv6. And I also told you that it does not require a subnet. So what I meant by subnet is that let's say we have 192.168.0.1 slash 24. By 24, what I mean is that 3 bits are reserved for network, right? So 8 8 into 3 24, so 24 bits. So I am telling to my device that hey, this particular IP address I am assigning to you, and your subnet is 24, which means that you should be in class C of IP. So your device will get this particular IP and it will understand that I am a class C IP address. Based on that, it will only communicate with class C IP address, because communication happens from IP to IP within that class only, within that class only. And that is the drawback of IPv4. Whereas for IPv6, that's not the case. Without any subnets, without anything, it keeps on routing the packets. It does not require any sort of subnetting. Yes, they have subnets, but this is not the purpose of subnet here. The subnet here serves a different purpose. It is for routing the packets according to the requirement of the admin. That's a different purpose. But you can route it to any subnet. From any subnet to any subnet, you can route the packet. That's not a problem with IPv6. That's the advantage. That's why it uses any cast, right? So that is one thing. Now, what else do we have? So for IPv6, the default IP, if you have a device which is having IPv6, I'll show you shortly. It will have a default IP as this notation. Make a note of it. Dot 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 dot. So 2 colons is a default IP. Default IP for IPv6. And if it is having this and a 1, this is the loopback IP. So I told you for each interface, there should be a testing interface. For IPv6, this is the testing interface, the loopback interface, and it is annotated as like this, 2 colons and 1. So if your machine is stuck at this particular IP, this means that your machine is assigned with a IPv6 loopback address. If it is stuck on this particular IP, that means your machine is assigned with a dot dot and this, right? Is that clear?
Yes, sir.
Great. Okay. Now, think if I continue, we will get confused. So today, what all we have learned? We have learned about private IP, public IP, the basic of how the network bit is interpreted and how the host bit is interpreted, right? And how many IPs are there in that. Okay. And just remember one point, that is, if you are trying to annotate a network portion of an IP, it will be 255, and if you are annotating a host portion of the IP, it is 0. So if I ask you for 192.168.0.1 for this particular IP, can you tell me the subnet ID now? Right, this is a /24 IP. Can you tell me the subnet ID or subnet mask?
255.0.0.0.
No, no. I told you this is a 24. So that means that it already has 8 bits of network, 8 bits of network, and 8 bits of network. Only one host bit is remaining. So according to that, network bit is annotated as 255, 255.255.0. So this is the subnet mask for this particular IP. This is how your computer also will understand. Okay, this particular IP. It will not check this one. It will not check the slash, because that is not what it is capable of. It is capable of understanding it like this, right? Now, what if I give you the IP 10.7.8.1? For this, what will be the subnet ID? subnet mask.
Is it wrong also? No problem, no, sir.
Yeah, no, not a problem.
255.0.0.0.
Great. So that's correct. Because this is a class A IP and I already showed you the annotation here as 8. So 8 bits we are interpreting it as the network. Right? Simple. Now if it is 172.16.0.1 slash 16, what's the subnet mask?
255.255.0.0.
Great. That's it. So that's it.
Sir,
Hmm?
if we take 21, we are taking 8, 8, 16 and 24 now, sir. If we take 17 or 21 or 19 or 4, what will be the uh,
Right. I got your point. That is what is subnetting. So that is the next session.
okay, sir.
So if this value is 18, right? So and the IP over here, what we see is a class B IP, and according to class B IP, you are aware that it only has 16 bits reserved for network, right? But I told you that it is 18. That means that there are 2 bits which are borrowed from the host portion, right? This borrowing and this calculation will be confusing. That's the reason why I didn't take it up today,
Okay, sir.
right? So
And
yeah,
you have told about IPv6 Anycast, no, sir.
exactly.
IoT devices will be using that. The ID of Anycast will be the same, or it will be unique.
It will be unique for each and every device.
Like we have thousands of IoT devices nowadays,
Exactly.
and for every IoT device, the ID will be different.
Exactly. You can see 2 to the power of 128. How much? Just calculate this value. So that's the amount of IP addresses you can use. But in IPv4, it is 2 to the power of 32 only. Only 4 billion. But just for 2 to the power of 32, we have 4 billion of IPs. 2 to the power of 128, we will have more than 4 billion. So that is more than sufficient as of now, and for future purposes as well. So it's not like once this IP also is exhausted, we will not be able to use it. IPv6 is in a different sense. How it is going to work is, for private there is no issue. For private there is no issue because these IoT devices, they operate within your network. So you will be using the IoT devices at your home only, within your home Wi-Fi router. You will not connect the IoT device to a public interface, and then that public interface will be trying to advertise. So this Anycast will only be happening within your private atmosphere. This Anycast will not be routed. It will not be routed outside.
Got it, sir. Got it.
Yeah.
It says our mobile phone only.
Yes. Right. So that's about that. So before we wind up, I'll just show you how the interfaces actually look like. Just a second. Okay. Okay. So, so if you see this, I ran a command to check the IP configuration for all of my interfaces, right? So I'm telling ipconfig slash all. So you can see how many interfaces are here. So there is a Windows IP configuration here. There is a wireless LAN adapter configuration, wireless LAN adapter for the second network, right? Now we have the Ethernet adapter using which I am currently connected. Okay. Next, we have the Ethernet adapter for the virtual machine which I have on my device. Then the other Ethernet adapter for my virtual machine which I have on my device. Then the Wi-Fi. Then the Bluetooth. Right. Now, if you see here, yeah. So if you see here, my Ethernet adapter, when I get connected to my internet service provider, you see they have provided me, see DHCP is enabled, yes it is enabled, auto configuration is enabled, yes. So DHCP is in auto mode, that means automatically the DHCP IPs will be assigned to me from my Wi-Fi router. Okay. And then if you check here, the IPv4 address is 192.168.0.108, which is the preferred address. So if you see this, this is what my DHCP has provided to me. But when I'm looking at my mobile phone, I see another IP, that is 192.168.0.150. So DHCP server will keep a table of the MAC addresses to which it has assigned the IPs. So we'll come back to the layer 2 and the advantage of layer 2 regarding the IPs and all. But as of now, what you can see is it is providing me IP this one, and it is trying to understand the IP based on this. It is trying to understand the IP based on the subnet mask. You can see 255, 255, 255. Right? And you can see the lease obtained period and the lease expiration of that particular IP. So 15th May 2024 at 11:28 a.m. I got this IP assigned, and after a day, I mean after tomorrow at after this time, this particular IP will be expired on my device. So my machine will communicate with the DHCP server, that is my router, and it will send a offer request there. It will tell that DHCP, the DORA process will start, discover, offer, and all the steps will be taking place there. So using that, it will get assigned a new IP address, or the router can provide the same IP address. If it sees that, okay, this IP address is free, you can utilize it for the next 24 hours, not a problem. Right. So the why I brought you here is to show you the subnet mask based on how the IPv4 is actually having. Right. I don't have IPv6 address assigned, but yeah, my virtual machine adapter has IPv6 here. You can see link local IPv6 address here. So my virtual machine has a IPv6 address here, which is in the hexadecimal format as we just discussed. Right. So it is annotated like this. If there are two dots in between, that means that that portion is 00000. Right. After this hexadecimal notation, I see that there are two colons. This means that between this there is 00000. So in order to avoid that 00 portion, what they do is they just add two dots here. After that, we have the other bit, then maybe the subnet, and then the interface ID, and so on and so forth. Right. So that is how it actually works. Next, maybe in layer 2 we will discuss about physical addressing and how the negotiations happen. That's a different thing, but I believe this is understood to everyone. You can see the network mask here as well for class, because this is a class C IP, it is assuming it as class C subnet mask only. So
Yes,
now,
sir. In the Ethernet adapter, we are, sir, once go through Ethernet adapter once. Here we have DNS server as 49.205.171.194. Is this private IP, sir? Is that your ISP provider giving you this IP address?
yes, this is the public IP. So I told you that the IPs and the default gateway and all the IP related information is provided by whom? Provided by the DHCP server, right? So my ISP, which is Act FiberNet, what it is doing is it is providing all these other informations for private IP, because they want us to route it internally only. But for the DNS, that is the domain name server or domain name system, for that purpose, for DNS resolution, it is providing me public IP. That means if I want to go to google.com, the initial thing I have to request for is the DNS server to provide me the address of google.com. So if I do name server lookup for www.google.com, you can see the server address over here is hyderabad.dns.accord.in, and the address which is resolving this particular query for me is this particular IP. Generally, your device might have a public IP or it might have a private IP. That depends on the configuration what your ISP provides. But after it reaches to your default gateway, the next step is that it has to be natted outside of the device. So we'll come back to the natting concept also later. What it does is it basically converts the private to the public IP. That's it. So we'll see that. So this is how it actually works. So I believe everybody has understood this.
Yes, sir.
So if I go to the network configuration here, um, let's say I try to change this one. Okay. Now if you see here, I have IPv6 enabled and IPv4 also. If I double click on this, let's assume that I am configuring the IP manually. Let's say 10.0.0.1, right? And I will not do anything. I will just bring my cursor aside. If I come here, you see subnet mask is automatically coming. It is telling that this is a class A IP, and obviously my subnet mask will be this for this class A IP. This is by default. But tomorrow, if you are using subnetting and you have configured some subnets among this particular IP address, you can also configure a subnet mask manually. So that depends on how it is going to how your values come about based on subnetting. So by default this value is generated. This is auto generated value the moment it recognizes that. So if I click on this and let's say I configure 172.16.1.1 and I click on subnet mask C, it is bringing me to the 255.255. So this means that these two bits, these two portions are the network portions and the other two portions are the host portions. So your system will look for 172.16 considering it as network, and whatever other values are here, these are the host portions. So that means that you can communicate with the other host. So what this indirectly means is that let me bring up this. So let's say let me ping my default router, ping 192.168.0.1. So I told you that my IP is this, but I am trying to ping 192.168.0.1. Why am I pinging? I'm just checking if that host is available or not. If I click on this and I hit enter, see, I am getting reply. So that means my router is sending me the response back. It is telling yes, I am active. Don't worry. So I send the ping request from this IP, right? I sent it to this one. How did it understand that I am trying to ping this one and the subnet is so and so? It's simple that your system knows that this IP, right? This IP belongs to type C, and whatever IP you are sending the request to is also type C IP because it checks that network configuration. If at all you try to ping something which is out of the scope, you will get you will not get any response. See, it's stuck, request timed out. That means that there is no routing there. So there is no path for this particular packet to go out. So you are trying to ping from one class of IP to another class of IP, and there is no routing protocol in place. You can route one class of IP to another class of IP, but that is only possible when there is routing protocols in place. So in that routing protocols, you will just configure a simple NAT. That is, you are natting a class A IP to class B class C IP, let's say. So that is called as natting, just to convert it into a understandable format for the other class of IP. So that is what it will do. We'll come back to that in the later session. So I believe you have understood this as of now. Cancel the changes. This is not required. Uh, mhm. Okay, there is no status icon for that. Okay. I don't think so. IPv6 is assigned. Yeah, there is no IPv6. The only reason is I have disabled that. Not a problem. I believe everybody understood the concept.